So if you think the calculation is too hard, in the end, we are going to show you the MATLAB code. You use computer. No complaint for the computer. They can solve it very quickly. Well, before I use the command, I want to review a little bit about the normal distribution. I don't consume you all on the statistics, but more or less you know the bell shape of a distribution, such as the average height of a man maybe 5'8", and there are some people are very high, like 7 foot. There's some people very short, 3 foot. Roughly speaking, you have a bell-shaped distribution. So is your GPA average score. Most people could be on average 75, let's say. Somebody may go to 100, or somebody may be only 25, felt miserable. The following the distribution like this if the observed data set is big enough. So in this bell shape, typically you have 2 parameters. One, we call it the mean of the or expected value. That is the number here. We call it mu. And the height example is 5.8. Average score mu may be 75. Depends on who is teaching. Another parameter is this sigma here in the formula. The sigma, we call it the standard deviation, or the sigma square, we call it the variance. Let me write it down. Here you go, standard deviation. And this deviation will tell you the distribution of the shape could be very concentrated around the mean, could be spread very far away. It depends on the characteristic of the data set. Let's look at another graph. Now, this is 4 different examples. 3 of them, they all have the same mean, mu equals 0. When the mean is 0 in the signal processing or other application, we call this as a white noise. The white noises, we only need to think about the other parameter, that's the deviation. It depends how much it is spread out. And that's the standard deviation. Well, the green one here, your average is -2. That's just the shift. And the 2 parameters will completely characterize the data set in the statistics. Let's look at the third concept about this standard deviation. Well, to describe where you stand up compared to your peers, sometimes we can say you are on average. If you are right here between 1 deviation of the average, and the 1 deviation, this is the average, this is the average plus 1 standard deviation, that will cover the positive 34%. The total from the left to the right depends which side you are. This is above average, that's below average. So this one will say where around the average. It take a total 68% roughly. The next one is the most frequently used one. We call it 95% confident interval. 95%. That around 2 deviations. that's around the 2 deviations. And then the third one, if you get the 3 deviations, that will cover 99.7%, practically everything. So if I give the grade, in this case, I might give an average grade here, and above average here, and the A here, and you can think about it, that's a D, probably F. That's a typical way we give the A, B, C, D. Well, that's not a secret, right? So now, since whenever we do the measurement or we do a mathematics modeling, the errors are inevitable. If that's inevitable, instead of give a solid straight line, say, hey, here's the relationship between the chicken and the food it consumes, it's better off to give a range of different feeding lines, and then you say, that's probably the good estimate based on our data. So let's look in the next. We give a so-called 95% confident interval, and to look another application. In this application, and we assume the gas per gallon of gas consumed in a mile driving of the car is proportional to the weight of the car itself. So, or say the horsepower of the car. So in this case, we got a set of data. And then we not only give you one single line, we get you a bundles of lines. And in this case, you can see the shaded area. They are all surround the feeding line in the middle, but the interceptor has a range that we call it 95% of confident interval of this beta 0. And you from the middle point, you can observe the slope also have a little range. This beta 0 got the low boundary and the high boundary. That's again another 95% of confident interval. And when you use the MATLAB, you're going to interpret this concept. Well, you only need one keyword, means regression. And if you want to learn how to do it, all you need is say help, regression, and then the MATLAB will bring up all the examples and show you how to do it. You copy paste, you can make it quicker. So what is this example? Okay, this is back into the chicken again. And this is the 10 data set. And the egg is a matrix. The first column is all 1, just basically 10 ones. I'm going to explain why you have these 10 ones. The second column is going to be the weight of the first chicken, second chicken, and the fourth chicken, all the way to the last one. Well, then your equation is this. Y is the food the chicken consumed. It's a 10. You see, when I put this prime, I transpose, it's column of 10 elements. Put it this way, 8, 7, 1, and to the last one. Well, then all you need to call is the Y, the X matrix. What does 0.05 mean? That is 1 minus 0.95. Just say, I want the 95% confident interval. That's, if you want the 99% of confident interval, means the 3 deviations, you can put the 0.01 here. Will give you a little more wide range. So when you solve that, the solution have 2 components. One is the B. What's the B? This is the interceptor, beta 0. This is the slope, beta 1, on average. And this B int, this int means the interval is the 95% of the interval. You see, the B lower bound is 33, high bound is 77, and the span between the two is about 44 divided by 2, that's 22. So let me draw it. The shape average is 33, let's say, no, average is 55 as the intercept. And then here's 33, 77. You remember that the 95% covered approximately 2 standard deviation. Then you can figure out that the standard deviation is around 11. That's the idea. So is the slope. The slope has the average 7.69 and the deviation from 3.28 to 12. And you can see this is how much is spread out. And then you get a little more reasonable solution. Instead of tell the manager, this is our solution, the chicken weight and the food consumed is a straight line, you are going to say, if any chicken, their relationship is between these 2 parameters, then the normal range. And that's what it means.